Conference will now be recorded.
Right. Just to introduce myself, guys, myself Ravinder. I'm working as a tech lead in my current company. So I do work on uh, Microsoft SQL Server, MongoDB, Postgres, MariaDB, MySQL, including the cloud technologies. So I do work as a escalation engineer. So every day, day-to-day life, I do go through different kind of issues that I have to handle as part of my profile. So MongoDB, on MongoDB close to 9+ years I'm working right now. So on the whole, I do have close to 19 years of experience into IT industry. So I do have a lot of passion to learn new technologies. At the same time, working parallelly with my current profile. So that's how I adapted to different technologies since very long. I'm training also on the different technologies since very, very long. So this is a little bit introduction about myself. So we'll come to today's agenda. Today's agenda, we're going to understand why noise skills are shining in the market when we have RDBMS products since very long, like 1960s, in fact. Why the noise skill technologies are getting adopted and what are the use cases noise skills are really fulfilling compared to RDBMS. What are the comparison, if we compare with RDBMS noise skill, what are the differences we do have and what kind of market we have, and you understand why market is looking for noise skill technology by the end of the today's discussion. That is overall agenda to make you understand what is noise skill technology, out of it where MongoDB fit into, why we need to learn, what is a need in the market, everything we're going to get by the end of the class. This is more of informational, nothing technical today, but try to follow, like, we will start the technical in the product only, but for now it's about comparison between the noise skill and RDBMS. RDBMS we do have, but why we don't repurpose RDBM itself, why we are adapting to the noise skill, you get the full answer for that by the end of the class. So let's talk about the objective, why noise skills are required. Basically, if you talk about RDBMS, RDBMS is quite sophisticated product. They do process any amount of data, right? So, but still noise skills required. Why? Basically, there are certain use cases which we will go through in the next slides. Basically, and benefits compared to RDBMS and noise scale we'll see, and the terms what we use in noise scale, what we use in RDBMS, basic terms basically. So I'm going to introduce few of the differences in terms of objects. How do we call them? Different types of data NoSQL databases. In RDBMS also, we do have a group of a stack of technologies, right? Oracle, Microsoft SQL, Postgres, MySQL, MariaDB, Greenplum. There are many RDBMS technologies. The similar way, in NoSQL also, we do have different vendors develop their own products. And what are those which become, popular in the market? I'm going to I listed the products in one of the slide. I'm going to tell you what are really shining in the market, what not. But anyway, just you need to aware of the names, what products we do have under NoSQL technology. And we're going to talk about cap theorem. Cap theorem we'll talk about in the architecture anyway. We'll see. I mean, if we get a time, I'll talk about this too. We'll see. So NoSQL technology, it's not a new technology. It's invented in 1998 itself, right? If you talk about how many years ago, 27 years ago. So it was invented by the person called Carl Stroji in the 1998 itself. But when it was invented, there was no response from the market. NoSQL started gaining the market, like here and there, 2010. Before that, there was no much market for the MongoDB or NoSQL technology. In fact, it started after 2010 itself. Before that, there was no NoSQL implementation. You are hearing this NoSQL product since few years only, right? Before that, not much of usage in the market. Why it is so? Basically, if you talk about like example from 15 years from now, 15 maybe like 18 years from now, you really don't had smart devices in your hand. There were hardly people used to interact with the computer, used to generate the data in a particular format, and data was actually controlled. Data was absolutely controlled. There was some structure where data used to be entered by the application, system used to accept it. But now everybody have a different device and they're generating the data. That too, data is a different formats like structured, semi-structured, unstructured. So this kind of data is no cannot handled by the RDBMS. RDBMS is fully structured, product where you have to define the structure and then load the data inside the structure. Okay, so NoSQLs are not like that. You don't have to define anything; it still accepts the data. So before I go to this one, let's understand the architectures. Okay, the architectures of NoSQL architecture of RDBMS. Then take you through the point by point to make you understand, because this is what is going to make the difference between the RDBMS to NoSQL basically. So let's go through a little bit of background things. Then I'll come back to the slides part to make you understand every point that I've written on the slide anyway. So if it is RDBMS, what do you do basically? You stand up a big machine and you'll have a database, right? It can be one database or multiple databases. So you will have more data drives, uh, okay? And you'll create the file groups concepts where you can stripe the data to different drives, which is good enough. But if data growing bigger and bigger, what do you do? Expand the drives, existing drives to accommodate the data. So this is a common story in the RDBMS. So you spin off machine and then you add the required drives and you create a database and the files in each drive. And if a database is growing bigger and bigger, it is consuming all your storage in the disk. You expand it to accommodate the more and more data. That's good enough. But when the data grows too big in a single server, that's where the limitations comes on the RDBMS systems. In fact, if example a single database can become 10 TB, you can process the data. There is no issue by deploying more and more CPUs and more RAM in a single machine. The problem comes when 10 TB data, if you have a TBs of table size, one of the table size itself in TBs, you can't do the maintenance time to time, because given maintenance window is not sufficient to rebuild the indexes. If you can't rebuild the indexes, the statistics will outdate. If the statistics are outdated, the execution plans will definitely go through the scan and then they will create the bad performance down the line. So when the databases becomes too big in a single system, you can't do the maintenance properly on the tables. Even you do the target table by table, week by week. So you're not able to do every table maintenance because of the size that you have in the database, and because you are not doing it, you are going to lose the performance badly down the line. So this is going to be a limitation in the RDBMS because of the size of the databases. When they grow real bigger, we can't do the maintenance within given windows. One weekend or whatsoever they're giving a window, you can't do every table maintenance. If you can't do, they are keep changing it. The statistics are getting changed, and the performance will degrade as they're getting changed. So what is a NoSQL architecture basically? NoSQL architecture is different story. So just let's compare. I'm not finishing anything today. I'm trying to compare the product, nothing else. So don't carry away that you're not getting anything kind of. So just try to understand what I'm trying to discuss today, because we're going to discuss every module in detail. You definitely understand. For now, I want to make you understand the differences first. What kind of architectures we have for NoSQL, what kind of architecture we have for the RDBMS. So let's compare this. So I'm just drawing this architecture. This is about NoSQL sharding technology, which scales with any amount of data. There is no limitation on the amount of data can support, unless you keep add the more machines, the more scalability you get it. So this is called Mongoose router. Let me draw this and then I'll explain how exactly it scales with any amount of data. And it provides even better availability, scalability compared to RDBMS, basically. So these are all shards are replica one. You can say that replica one or shard one. So what are these terms? Don't worry about terms. Understand the architecture side, what I'm going to compare. Shard two. So basically, your applications will hit the router server. Router is like a listener here in an, MongoDB, and this will go to config server. Config server will maintain all the shards information inside the config basically. So how many shards, how many replicas we have. So this is going to write the data into, like all the shards parallelly, reads data from all the shards parallelly. So here example, if I'm loading a table or table called collection here, example, if I'm loading 100 GB single collection. So single collection will go to 33.3 data will go to here, 33.3 GB will go here. So we are dividing the data into different servers, not into the disk. In RDBMS, we can do the table partitioning, we can do the file group, that kind of concepts, and can stripe the data to different drives. It is possible. The table partitioning are file groups and files within the file groups basically, and table spaces in, each table space can be mounted on a different file system. It is possible basically, but within the system you are limited to one machine. That's a big problem in the RDBMS systems. So when it comes to the NoSQL, it follow the mesh. The data distribution happens on different machines basically, and each segment again protected with the multiple copies of the same data. These are all replica sets. In fact, equal to every replica set equivalent to your always on. Okay, in the SQL Server, it is streaming replication. Whatsoever you can say that. Even in the MySQL Postgres also we do have replications, right? Similar to, you'll have exactly server level copy one to other to protect the data. Even in the event of this is failed, other member will come take as a primary role. It will serve the group, in fact. So what I want to cover here is, even irrespective of data, your data is getting distributed to different servers, not within the server here. If your data is growing, example 10 TB, whatsoever, you add more shards here. Okay, you add more shards. Data, as soon as you add a new shard, existing shards will push the data to the new shard automatically to balance the data. That something is taken care by the sharding technology. There are certain process which will migrate the data. Auto balancer, if it sees a new shard added to the group, it will move exactly 33, 33, 33, right? So it will become 25, 25, 25, and 25 will be migrated here automatically. So altogether 100 GB. So the sharding technology is a technology which will migrate and distribute the data automatically to balance it on its own. You don't have to do anything. Technology does for us, in fact. So here, what I wanted to convey really is, RDBMS is a good product. It is sophisticated. They are selling fine in the market. They never go out of the market for sure. But there are limitations when it comes to the data growth within the machine. You can't scale with any amount of data. There is a limited data where you can scale. There is a limit. Limit in the sense, the product can support 100 TB also. That is fine. But the problem is the maintenance. You can't do the maintenance on such a big databases and such a big tables within a given window. If you can't do, you definitely lose the performance, and scalability is gone, right? So the scalability is gone. That's why NoSQL follow the different trend, a different data striping mechanism into different servers, in fact. So here we call this as a vertical computing power. In all RDBMS called as vertical computing power. These are all the terms we use actually. So just for the sake of vertical computing, and here it is a horizontal computing, like you are hitting connection, the single connection going through multiple machines, all the machines. So you are scaling horizontally here, horizontally. Okay, horizontal computing model, which mean single request served by lot of servers in the background. If you look at the all social media platforms are running on the NoSQL platform. All social media, you talk about Twitter, you talk about Instagram, Facebook, any product you take it, all are running on the NoSQL technology only. You never see the page is actually timing out, or it is getting blocked in the background. You are not able to see the data. It never happens because there is an architecture. I'm going to cover that in our course. Why Facebook never hangs. Even Instagram, there are hell lot of like millions and billions of people accessing around the world at one go. Still, we never see the slowness on the portal. Why? What the mechanism it follows? We have the architecture where I'm going to talk about, because this is comes from the NoSQL technology only. So one thing, guys, I want to cover here: if it is NoSQL technology, your data got distributed to different servers. No one segment is having all the data; it is having a chunk of data. If one chunk goes down, assume a case, it is if 25% of the data is gone, 75% data is still operational. You are not completely down in this architecture. Because of any reason, your cluster, one of the segment is down, rest of the segments are online. They accepts the operations whichever the operation is falling in this data range. This data will be down. You still operate the data and the rest of the range of shards. In fact, you're not fully down. If it is RDBMS, example, a small portion of the disk is corrupted. If it is SQL, or example, 1,000 pages are corrupted, then your 10 TB or 100 TB database doesn't matter. 10,000 pages equal to 10 MB roughly. 10 MB data corrupted, 100 TB database will be down. You can't operate the database at all. It is completely not operational. There will be no recovery. You can't see any data absolutely, because of 10 MB data corruption physically. 100 TB data is gone. Absolutely. Single point of failure. Absolutely single point of failure. Here we see 25% data is lost. Still 75% of the data is operational. They are available and you can still operate on it. We are not losing entirely at one go. So this is also a big failure, of course, compared to this one. And availability wise, scalability, anyway, you're going to get, you're reading from multiple machines, writing into multiple machines parallelly. Okay, getting the scalability. High availability, basically you have every chunk. You need more servers anyway. That's there compared to RDBMS. NoSQL requires more servers, but they are commodity servers, cheap hardware. They are not costly hardware, because we are not putting all the data into one server. We are putting the data into multiple servers. You no need to have a high class software, high class servers hardware. You don't need it. Cheap hardware also will work here. That's why you deploy your infrastructure to save the money. In fact, so it gives
Uh,
us, yeah.
Ravinder, I have one doubt here. So, up to maximum, how many replicas we can go with this?
You can go as long as you want to deploy, how many shards you want to deploy. There is no limitation. There will be, if you go to Facebook and Instagram, they'll have 1,000 shards at one go, 1,000 even more.
So,
How
this
you
is
are?
we need to decide while doing the configuration, or automatically depends upon the load, so it will get increased automatically.
No, no,
We
it's
don't.
not automatic. You have to analyze your server data growth, and if your servers are suffering the performance, though you took all the measures to improve the performance, still it is not scaling because of the data operations. We can track, right, IO operations, how much is coming in, how much is going out, and what the system capabilities. So if you see such kind of metrics are going beyond the capability of existing, you add one more, you add one more, so that they scale automatically.
Okay, and I have one more doubt here. And we have data of 1 terabyte for each replica, one, two, and three. And we are
Mm,
adding additional replica called three. And it will
mm.
be one and two will be going to share the data, right? So this one it will happen with a business time, or it will be going to happen non-business hours. And
It is in the background. Like during the business hours, you start adding one shard, automatically it'll push out the data. So there is something called auto balancer. You start the auto balancer, it will start migrating the data. You don't want the data to be migrated during the business hours. Stop that service. Actually, it is not a physical service, a logical service. You just run one command to stop the auto balancer. It will not migrate the data. So it will not create any
okay.
issue to the business. Non-business or
So
start the service, it migrate the data.
okay, if in case if you are migrating the data, then if it is any performance issue will occur.
Yeah, of course, because it is migrating in the form of chunk. Each chunk equal to 64 MB. When it is migrating one to server to other server, there will be network congestion, right? When it is moving the data around, there will be,
Okay.
and compute power also can consumed. So there will be, but if it is a known, you can compromise. Maybe a day or two. It will, if you add a new shard, it is going to sync. It is going to take time. So during that time, there will be you definitely experience some performance delay. because of this chunk migration.
Okay.
Okay.
Yeah.
Right. So coming back to the another part is NoSQL. So come on, I want to show the another difference. Let's don't worry about this. What I'm trying to do here as of now. CD okay. I guess I have MongoDB running. Let me check. Don't worry about exactly what I'm doing. I'm trying to really show you the difference, nothing else. Mongo SH. Okay. I have the SQL Server, which is a part of RDBMS. This is a NoSQL, which is a MongoDB. How they are different in terms of data acceptance? Let's see that quickly. Example, I'm going to create a table quickly. S
In
number,
SQL,
integer,
data will
S
be going to
name.
store as rows and columns, right, as a table. The MongoDB also is the same, or it will store
I know
like
that
unstructured data.
that's what I'm trying to talk here. So let's see that in action. So yeah, RDBM is a rigid schema model. What exactly the word what I'm saying rigid means? See, I defined a structure here. I defined a structure called three fields here. You can see is S number, S name, S address, three fields. If I want to load the data into this table, I can load the data, insert into student, right? Values, and I'm going to load some data here. Example, anything here. I'm just trying to load some junk data, whatever it is. So if I'm loading this data, it will accept. Why it will accept? Because the number of columns, the data what I'm supplying to the table is absolutely fitting. That's why it is accepted the data. It accepted the data, it loaded. If I'm adding one more, like phone number example, I did not define that as a field. I did not define in the table. If I try to insert it, it will fail straight away, saying that the column name number of supplied values does not match the definition. You defined only three columns and you're trying to load four column data. Where do I fit? Where do I load? You can't. RDBMS always you define the structure in the background and you have to load the data within that structure. You can't exceed the structure. If you are exceeding the structure, this is what happens instantly. You can't, it can't accept the data. When it comes to the NoSQL, it's a fully dynamic. It will accept any data in any format. It doesn't matter how you are putting the data in the system. So how exactly? Let me see. Example, I'm going to use DBA. You don't have a database too. Everything is dynamic, absolutely dynamic. DBA, I'm creating it. Database does not exist. It will create the database automatically. And under the DBA database, you don't have any collections. Okay, show collections. Don't you worry about this. Understand the concept. It is empty database. So db dot student insert. I'm trying to insert the data here. So s number one, s name. Let's give it s number one itself. First record. It is accepted. I'm going to second record. Second record s number two and s name. I did not define anything for that student table. It's equivalent to table in fact. Example, Ravindra, I'll give it. So here, if I load it, it accepted it. If I go to third record, okay, here I'm going to give it as address. So every record is having different structure. In fact, it's still accepting in the same table, student, student, student everywhere. Okay, so if I go to here, I'll go with phone number. So if you go and read this table, the data look like this. First record is having only one field. Second record is having two fields. Third record having three fields. Fourth record having four fields. Every field is independent. There is no structure. How your data can be in any format, it will accept the data. It can be structured, semi-structured, unstructured. Nothing to define in the background. You don't have to define anything. It's a dynamic. It accepts anything as a dynamic model, dynamic data model. It never reject any kind of data. So RDBMS it can't see. Nowadays everybody are using the social media. They are writing different text. Someone is uploading the video, someone is writing the text, someone is doing different formats of data. That is something you have to define in the RDBMS. If something comes as a new, you have to define, then only it will accept. But NoSQL, no. You don't have to define, and everything is absolutely dynamic in the background. Front end, whatever they define, what it happens in the background automatically. No database creations, no table creations, no structure definition, absolutely dynamic. It accepts anything for that matter. That's where the NoSQL came into picture. And this not only this, basically there are many other points I'm going to tell you. This is one of the biggest selling point for the NoSQL products. They do accept any data in any format, structured, semi-structured, unstructured, it doesn't matter. It just accepts the data as you're pushing the data to the system. It never rejects unless you create your own rule set. How you create a rule set is a one module we have, schema design in MongoDB. You have to give a kind of constraints, like if I follow this, then only accept the data. That's something we will see in the another module. So if you come to the RDBMS products, all RDBMS products are rigid. In fact, by nature, we have MySQL and Postgres. They are supporting the NoSQL also natively. That's a different story, but very limited functionality, not full functionality. But this is made exactly the NoSQL technology, no structure, no relation. Absolutely, NoSQL means no relation. There is no relation between the row to row itself. Table to table, you leave it that part. There is no joining statement you can do in NoSQL technologies. Every table is independent. They don't have any. You can't create the relations here. Non-relational database. NoSQL basically non-relational. There is no relation. In fact, it accepts the data in any format. Absolutely. Okay. So this is another point. The third point I want to talk about is open source. This NoSQL, if what I'm trying to say, this entire architecture I can build in the community edition. Community edition means free. We are running multiple clusters in the community edition. Community edition, there is no limitation on the amount of data that operate in the cluster. I can run 100 TB or 1000 TB. It is possible in the community edition. There is no data limitation. There is no computing limitation. Only thing is that you can't monitor the data using automated inbuilt tools. You can't upgrade easily. You have to do it yourself, everything. You can't monitor well. You can't do the encryptions. You can't do the in transit encryptions. There are certain things which you can't get with the community edition. Only features, not the amount of data what you operate in the community edition, the enterprise edition. Only the features are missing. You can operate any amount of data. You have a good DBS can support anything using the homegrown scripts. They developed their own scripts. They are monitoring well. Absolutely fine. You don't need to go to the enterprise. You can run everything in the community edition. We have in MongoDB 95% is open source. We are only going with the 5% is licensed enterprise. So understand, we are able to save 95% of the software cost. Only we are investing on the hardware. So that's how the industries are actually moving to the open source technology. Even MySQL, Postgres also have open source layer where they are pushing the licensed products to these products, and they are saving a lot of money. See, nowadays they know what is critical, what is not critical. If it is a critical, run on the licensed version and the RDBMS too. If it is not critical, push it to NoSQL, absolutely free. So people are smart nowadays. That's how the technology's footprint is growing in the market. A lot of different open source footprint is growing a lot in the market. MongoDB is open source, another big selling point we have. Let's come to the slide now. So basically, what I want to cover here is first the architecture. Architecture is RDBM is good. It's so sophisticated. It is running well. It runs also in the also. But the problem is the data what it handles is a matter here. It handles exactly structured data, non-structured data. It is not supported. You have to always define the structure. Then only you push the data. Then only it accept. That is the one thing. Second thing is single point of failure. I have 100 TB, 10 MB is corrupted because of 10 MB, 100 TB data. You can't operate. It is never be usable anymore. Entire data is gone, simple, straight away. You can repair, of course, the 10 MB data will be gone, but by default you can't operate. You have to repair with the data loss. Then the corrupted data will be gone, and the rest of the data which is operational will become online. That is there in here also. Even in the MongoDB also, data can be corrupted. We can we can repair even in the MongoDB also if it corrupts. Anywhere corruption can happen, obviously. If the portion somewhere it got corrupted, I'll exactly repair this portion. I don't touch other portions, other shards at all, because here I have 25% data, out of which few amounts of data is corrupted, and the shard is not coming online. I'll repair here. So that data, particular 25% data where it got corrupted, that will be repaired automatically. Here also repair can happen, obviously, but the problem is the operational capabilities. 100 TB data is actually gone just because of 10 MB corruption. Okay, that is completely single point of failure. But here I'm losing 25% data temporarily, not available, not operational. Still 75% data is available for the business. You're not completely down, you're partially down. That is another point. And scalability, we are writing to multiple machines, reading from multiple machines. You getting the more readability, writability to the systems, in fact, because you are not writing into one system, you are writing into multiple systems parallelly. Whereas in RDBMS, you can write into one machine. You might have the secondaries, of course. You can sync up to secondaries. From here, you can read, not write. Okay, in Oracle we have the concept called rack. Rack behaves little different, uh, in especially in Oracle itself. You can write into multiple machines, it is possible, but at the end only one volume, one storage volume, all will go to one volume here. So you are able to write from multiple systems, but you are writing at one storage at any given point. Here you have the the limitations again. So every machine is writing into one volume is equivalent to one is writing to one itself. But anyway, you are just hitting different objects. You get the more scalability of the write, but you are hitting one volume. The volume also will have IO capacity, right? At one go. So here, you are choking the system at one layer, particular layer, but here you are not. You are putting this data into multiple different machines and getting the data from different machines. You get the more scalability, more availability, as well as HA as well. Like, if this goes down, this will pick up automatically. If this goes down, this will pick up automatically for one each chunk, in fact. So availability, scalability, data availability is absolutely more in this architecture. Okay, and other big selling point for this product is the schema-less dynamic schema model, where RDBMS you define the structure, then you load the data. First you always build the background. You have to build entire, if you want to introduce a new functionality to the application side, you have to build the equivalent table structures, entire logic in the background, then you can go and deploy in the front end. When it comes to the NoSQL, you don't have to do anything in the backend. Backend is fully automated, fully dynamic. You do anything in the front end that happens automatically in the background. So that's a another big advantage. Let's come with the point by point here. So NoSQL means not only a skill or non-relational database. You can say that not non-relational too. In fact, is set of new databases that is based on non-relational, see, not based on relational database management systems. So database in terms of RDBMS, the principles are different and the NoSQL principles are different. So what kind of principles we have, we're going to talk in the architecture. Today I'm not going to inside the technical terms. I'm just justifying the difference of RDBMS to NoSQL, why they are shining or growing in the market as of now. These are all built for the big data platform. See, all NoSQLs by default big data. They're built for the business big data. In fact, what exactly the big data means? Huge data. It can scale with any amount of data. It doesn't matter how big or how small. If example, I have a small chunk of data, assume a case, so I can run in a single replica set. So how cluster can be formed? I have a single replica set. By default, you'll have like this. It's equivalent to our RDBMS, where you write data here, it will sync here and here. If one goes, other one will pick up it. But as soon as you feel like your single machine is not going to scale with your workload, you introduce a sharding. Okay, this is how. And again, whether you are going to go to the sharding or not, it is a depends on the revenue that the business is generating and how much data they are pulling and what is the priority of the business. There are many factors will be calibrated before we go to the sharding, because it need more infra means, are we really getting that revenue from the business? What we are operating here, you're not getting, let them suffer. We don't go to the sharding straight away. You have to equally get the money from the business so that you can deploy the infrastructure. We can't deploy the sharding for every technology, every application that you have in the company. It's a purely, the directly of revenue. You get the more revenue, you give the more power, more performance. Is that way in any product, right? It is simple fundamental thing, right? Coming back to big, it is a big data flow products because they do support any amount of data. There is no limitation in the amount of data what it supports. These are all new generation databases. That's what, if you go to your phone, you go to your Play Store, you go to any app, all of the apps are using the NoSQL only by default, because your data is not something no fixed. You generate the data in the app in a different formats. You can upload a video, you can write the comments. You can do anything in the apps, right? Almost all Play Store apps deployed in the NoSQL technology, not in the RDBMS, simply because they accept the data in any format. You look at most of the Play Store apps are does that. Their interaction will be, with the data set, the interaction will be can anything like, what do you see in the Play Stores generally? So Play Store apps are mostly are in the NoSQL technology. That's why it is called new generation databases. In fact, non-relational, there is no relation between the uh, tables. There is no between the rows. So there is no relation simply. NoSQL means non-relational. That way better. Not only SQL is a actual term, but non-relational database systems called NoSQL. Runs on the commodity hardware, cheap hardware. Why it runs on the cheap hardware? Because you are not keeping the load on one machine. You are having multiple machines. Your load is getting distributed to different systems. When it is getting distributed to different systems, they don't need to be sophisticated because they are processing minimal load for every request, not full load. So that's how you run the commodity, means cheap hardware, not server class hardware. So runs on the commodity hardware is another good thing. Open source is a big selling point. Open source is a big factor out of all, I would say. Why? Because everybody looking for the open source first thing to save the money. And what open source is a one big factor, and it is fulfilling more use cases too. What are the use cases? Dynamic schema model and more scalability, more availability. Everything is a considerable points for the business to consider the NoSQL as a product for them for running the business. Schemaless dynamic schema, we just have seen, right? It is accepting anything. So for that matter, if I go to command prompt simply, here it will show better. Mongo as such. Uh, host, what is it? Linux 02. Just is it connecting? Oh, it is connected. It's not. It said in fact. I have to give the double host. Okay, just a minute. I want to show in the command prompt. It will show in a better way. It is running on the Linux platform, but still, is it going through? Trying to connect here. Do I have a firewall? Just a minute. Yeah, it is stopping the connection then. I'll explain all this. You can connect from anywhere. You run the product anywhere. You can connect from anywhere. Right, it's connected. So show DBs. We have loaded the data in the DBA, right? Use DBA. Show db.student.find. Right, here also it's showing just like that. Okay, just a minute. I want to show this thing. Exit. Mongo. There is another binary we have. Linux 02. Is it connected? Nice. Use DBA. Show db dot. Don't worry about like I just want to show the data format. You easily understand, right? This is what. So first record, if you see, it has S number. Second record, it has the S number, S name. Third record has the like this. If you see, every row has a different hierarchy of the data. They are not same. They are absolutely different. So this is what is a dynamic schema model mean. It absolutely schema-less. You define anything, it just accepts anything that you wanted. It won't reject any data. Okay, your question should be if it is accepting any data, it will be problematic, right? Like how you there is a design rules. In fact, they should follow the design rules. What kind of design rules? I'll explain in the module. You can put any data doesn't mean that you can load any kind of data into one collection only. No, every if example you have a teacher's data, students data, admin data. If it is school example, student data should go to student collection only, teachers data should go to student teacher collection only. You should not club them. There are rules we're going to talk about. That way we will control the bad data. We'll talk about that in the course. Inbuilt data compression, you don't have to compress. By default we have you know a snappy compression model in MongoDB, which will compress the data by 90% if you have a duplicated data. When does compression can happen in RDBMS? Any product data compression when can happen? When it can happen? When you have a duplicated data. The more duplicate, the more compression can be done on the data. So this is a rule, guys. In any product, if you are compressing the data, compression can happen when you have a multiple duplicates. Example, we all from Hyderabad. All our address is Hyderabad only. For all Hyderabad, it will load in the table by default. If you compress, only one entry Hyderabad will be kept and the pointers will be given to the data. So it is going to compress. So if I have 1 million records all having as a address as a Hyderabad, for 1 million records only one Hyderabad entry will be there, and that entry will be given as a pointer, and that's how you reduce the size. So in the MongoDB also there is a inbuilt data compression at the server level. You don't have to compress yourself. You don't have to compress yourself explicitly. It's inbuilt by the product. It comes. If you look at 1 GB database size, but in the background it is 10 GB also. It can be 2 GB also. It can be 1 GB only. Depends on the duplicate data. The more duplicate data, the more compression you would see. The actual size of the MongoDB, the actual size of the backup will not match because of the compression by default. When you generate the backup, it is actual data. It is uncompressed data. But when you look at the in the MongoDB, what exactly I mean? Show DBs. I can see this database 0 size, 0 GB, 0 GB. Example, it's showing. Here, if it is showing 1 GB DBS database size, when you generate the backup, it can be 10 GB also because it is highly compressed database because there is a lot of duplicate data is there in the database. So the backup size of the MongoDB, the actual MongoDB size, what you see in the server, definitely differ if they have a duplicated data. So that's what is a inbuilt data compression. Compressions are by default come by the product. You don't have to worry about. It will be done automatically. If it is RDBMS, you have to do page level, table level. You have to target the table. You have to enable the compression table by table. There is no database level compression or server level compression in any of the RDBMS technologies. In fact, okay, it is there in the MongoDB. It does automatically compress your data if it finds any duplicates automatically. Highly scalable, obviously compared to rdbms runs in a one single system. Your maybe you have a standby, you are reading here, writing here, but for writes you are eating only one machine. Okay, there will be scalability issue. When it comes to the NoSQL, you're writing into multiple machines, so that's how you scale well. In your performance, read write performance will be more scalable. Mean highly available. As I said, like small portion of the database is in the RDBMS, a small portion of the database data is corrupted, entire database will be down, irrespective of the size. Okay. So when it comes to the NoSQL, no, even 25% of the data is down, still it is available. Data is highly available compared to the RDBMS. So it follows the base principle. RDBMS will follow the ACID principle. What is the base principle? What is the ACID principle? We'll talk in the architecture in detail. Don't worry. To get this benefit, scalability, high availability, right? These two, to get these two, you must run in the cluster. If you don't run this kind of cluster, you don't get the scalability and high availability. If it is a MongoDB replica set example, This is also like always on. You write into one machine, the rest are syncing from the primary. If the primary is down, one of the secondary will become primary. But any given point, one machine will be available. If this is down, you're gone. So completely gone. It is like a one. If it is replica set, it is like RDBMS. One single replica set equal to one RDBMS high availability. If you are going to the cluster, then only you get the scalability. High availability is mostly, more is possible compared to RDBMS when you run in the cluster. Cluster means this. This is a cluster. We call this as a cluster or sharding. You say actual word sharding. Sharded clusters. We say sharded clusters, in fact. Built for the new generation application. Obviously, as I said, these are all for the new generation. If you take about 15 years ago, there was no smart devices with the people. In fact, go ahead, please.
Yeah, I just have a small doubt.
Yeah, go ahead.
Yeah, so you said about the cluster, right? So we
Hmm.
can define like cluster is a group of shards or records, is something like that, or
Yeah, group of shards. One shard, second shard, third shard, fourth shard. Yes,
okay,
group of
okay, it's a
replicas.
group of records. We can simply call.
Not say records. They are group of servers. In fact,
Okay,
so it is one AG. This is another AG. This is another. All logically you are putting into one group. It is that way. Think that way. Always
okay,
on kind of. Okay.
okay, okay. Then. Thank you.
So each operate independently. They don't have any interdependency. You have the interdependency from the config only. When it comes to the shard to shard, when you look at from the background side, they are absolutely independent. They are tagged with the config only. Config only knows that where how many shards you have, where your each database exists, where each collection exists, where to push the data. It knows entirely. This will maintain the entire metadata. In fact, this mongoose will contact the config server to look at the metadata, then go to the respective shard, respective database, respective collection, get the data out. So that's how the relation. Anyway, I just barely discuss this. We're going to discuss very in detail. We have two types of shardings: hash based sharding, range based sharding. Both have different functionalities. We're going to go through very in detail, configure it. I'm going to show how data get migrated also in reality, how to monitor it, how do you regularly check it, how much data is there in each chart. We have every command, everything we're going to do in practical. For now, understand theoretically, because today I'm not getting anything technical side, it's only informational side. All right. So why NoSQL again? It resolves the challenges faced in storing, managing, analyzing, archiving large amount of data. If you want to do, you need a NoSQL definitely. Okay, you can't see in one of the technology, in of the one of the project we are doing this. So quickly, this is a SQL server. This is a MongoDB server. So more than 5 years data daily. In fact, there is a third-party tool involved in between anyway. It will take the data from the SQL server, load into the MongoDB. The same data will go into another table also. First, they load into archival table. From there, it will push it to the here. Once it is pushed, they'll truncate here. So, how it can be possible? This is also a good point of discussion we should have. In architectures, I'll talk about this again, but quickly. If you want to convert SQL data into MongoDB for any reason, you can quickly do it. So I have this data 16 rows. So I want to read this data into in NoSQL format. So this is the NoSQL format now. If you see the SQL data converted into NoSQL, in fact, it's a SQL data, but it converted to NoSQL format. Insert into. Just I want to show you this. Insert db dot just db dot uh, testing dot insert many. I convert this. I'll talk about this in our course. All this, don't worry. I'm just showing you. I want to convert the SQL RDBMS, any RDBMS. All RDBMS will support the JSON format, and that data will be accepted by the NoSQL. Hey, it's not copied. So here, let me load here. So it accepted. If I go and check the testing.find, so you will find the all SQL data converted to here. Let's go and read it here. It'll for the better readability. Testing.find. See, that data, whatever the data we had here, it got converted to Mongo. So this conversion directly not possible with the bulk data. There is a third party tool involved in between. We have that implementation. In fact, this is a licensed tool in between what is involved. So through that tool, we are pushing it to MongoDB and then cleaning up the data in the RDBMS system. So if they need the older data, we can query in the Mongo and give the report. So that way the things can work. So that's what is archival data. Managing, analyzing, archiving the data is possible. MongoDB accepts the data from every RDBMS system. Every RDBMS system will support the JSON. JSON is the only format the Mongo supports. So there are a lot of hierarchical benefits we have. We're going to talk. See, my classes is not what is what. I'm going to discuss every real world scenario that I go through. You don't have to worry about, because what is what you can get anywhere. It's not about that. So every class is like a workshop for you. Every class you follow me. That's it. I don't give any assignments. Whatever I'm going to discuss, I'm going to do use cases, scenarios. You just follow that and practice is that's enough to crack the interview and to sustain in the real world. Anyway, so explosion of social media data like Twitter, Facebook, such data, large data you can't manage with the RDBMS. At the same time, this data can be any versatile data. You can't really define such structures and then accept the data. They wanted to load any data, like if you define a varchar 255, so how many characters it can accept? 255. But they are writing even more, it won't accept, because you defined that structure, that column size, it will only accept that. NoSQL, there is no definition of size. You just mention the field as a text, that's it. It accept any big data, doesn't matter. It can go up to 16 MB. Anyway, that is also another limitation we have. We have a gridfs. There is another service to support any amount of data, raw file system. This is something I don't want to really finish right now, because we have one architectural thing. Data is a very big, in fact. You operate it as a raw file level, that we'll talk about. Continuous availability. Do you see that Facebook is going down or Instagram is going down? You never. Why? Because there are thousands of servers are working for you, not one. If one of the server is affected, still you have other servers to respond. So continuous availability is possible with the NoSQL, not with RDBMS. In fact, RDBMS is also possible at a certain level, not 100%. That's a problem. Need of need of flexible data model. See, when it comes to the this kind of platforms, they can't fit with the only rigid format. They can't operate with the defined structure model. They wanted to accept any data that user is feeding. It is, you should not reject. So for that you need a NoSQL, need flexible data model, such kind of products. The NoSQL database, great solution for growing scale of databases and falling price of commodity hardware. As I said, the commodity means cheap hardware. Cheap hardware compared to example, falling prices of commodity hardware. What it exactly mean? If you take 2 GB pen drive, even I purchased even 8 years 9 years ago, 2 GB pen drive used to be, how much it used to be? 2000 something. Because hardware was very costly, it was not developed much. The hardware cost was very high. If you take 2 GB pen drive, now 1 TB pen drive you'll get it for 2K, 2000, 3000 something, 1 TB in fact. So see, the hardware costs are coming down year on year. You can get 10 TB hard disk now, 10 TB hard disk for few thousands, like 5 6 7 maybe 10,000 below. In fact, 10 TB hard disk in fact. So even in olden days, you had to used to have a flappy and all that, right? The storage used to be very costly to store the data. Now everything is cheap. So as the data year on year, the rates are coming down. So it can operate on the commodity cheap hardware. You can deploy more hardware. You can run the data obviously. So it's data wise it is growing, and the storage wise it is falling down. The prices are coming down. It's a good technology, good solution for the business for managing such huge data, bulk data. It follows the column based stores, key value pairs. Key value pair in the sense here, this is a key, this is a value, this is a key, this is a value, this is a key. Field list is called a key. Okay, the value is called actually the value what we are assigning. In fact, you have a, see, this is a key. Which one? The column name. The data is value, key value, key value. Separately, every row has its own structure. That's why every field is repeated here. Unlike RDBMS, RDBMS field is only mentioned once, right? Data loaded there. But here, every field has, every row has its own field set and data. Data will be redundant here, obviously, because there is no relation. The more, if it is RDBMS, data will be less, basically. In, see, this small data, this is small data here, if you look at, compared to. But here in MongoDB, you see the more data. It is more, obviously, compared to. So um, this will be there, of course. When it comes to the NoSQL, your SQL data will become more in the Mongo because of the every row treated as an independent. Every row will have its own field set too. Key value pairs, that is called key value pairs. You have a field data again and again. Offers capabilities to handle large amount of data using the various features. Anyway, that I'm going to talk about here, features like here in the next module, next slides, we'll see that. Continuous availability, no single point of failure. We talked about multi-data center capabilities. What exactly I mean? Here we will keep two nodes in one data center, third node in another data center, this third node. Two nodes only in the primary data center. Even entire primary data center is down, I have these nodes available. I can make this primary immediately and can operate the business. It is possible. We're going to go through all this in practical. I'm going to break everything. Last single node, think like it is a different data center. I can make that online and run the business kind of. Every bad scenario I'll create in the class itself. Every bad scenario. If you have anything in your mind, I'll create that too in the class. It's not just to what I'm discussing. Every question will be entertained anyway. So easy replication, the kind of configurations are very, very easy in Mongo. Only thing is you need to understand the architecture, you need to understand the background data flow, and then you can troubleshoot. Troubleshooting power is more important. Configuration anyone can do in Mongo. Very simple. Few commands does the entire configuration. Configuration wise, MongoDB is very, very easy, but only your expertise comes in towards troubleshooting, in fact, in the product. The performance with the linear horizontal scalability, it scales with the more machines, not with the more disks. So that's how you can able to scale your workload, even performance wise, read wise, write wise, you can scale better than the RDBMS. Flexible schema model. Schema is always dynamic, what we have seen. Easy to implement and maintain and grow. Very easy to configure, very easy to maintain the data too. Comparatively, recovery is a little tough. Recovery is not as good as in the RDBMS. What do we do? NoSQL follows a different recovery model. I have dedicated one entire class for the recovery only. That's why I'll compare it at the RDBMS also. How you do in the RDBMS, how you do in the NoSQL, so that you get the full clarity, because you all come from the RDBMS background, right? So we'll see there. Open source community. This is a biggest selling point is open source, guys. It has many, many advantages when it comes to the, if you compare with the RDBMS. What are the points we do have? First is open source. Second is dynamic model, scalability, availability, right? So, and data inbuilt compression. So these all major points, in fact, to consider the NoSQL product for any application. If it is falling under that category, you have to come to the NoSQL. If the data is, if example, system logs every day will have every, one error can be few lines, another error can be 100 lines. It is possible. So you can't have that schema defined in the RDBMS. You want to generate the system logs into MongoDB. This can be done in every environment, will be done. In fact, they use a Splunk tool. Splunk tool will collect all the system logs and will load into Mongo. From the Mongo, they generate the reports. What is the health of the systems, in fact, using the there is one tool, in fact, Splunk, and forgot that name. We use it, in fact. Anyway, I'll check that. So built-in data compression, this is also another point. You don't have to do the compression, system does automatically. So compared to the, see, it's a rigid schema model. You have to define the schema, then load the data. It is dynamic schema. Anything will be accepted. It doesn't matter what kind of data you're loading. It doesn't matter to the system at all. It just accepts as it is. Vertical scalability, you give more power to one single system. You give more power, more storage, all good. but at certain point, at a certain size, you can't do the maintenance within a given window. If you can't do, you lose the performance. Here horizontal, irrespective of the size, I can do the maintenance because data got scattered to different machines. Data is minimal on each machine, so I can do and perform within a window. It is possible. Difficult to handle a huge data. That's what the problem with RDBMS. If you have a huge data in a single machine, it can't be handled. You can't do the maintenance time to time within a window. So that's where the problem comes. Okay, this can handle absolutely any big data because it's got scattered. Mix of open source and proprietary. If you talk about Oracle and Microsoft SQL Server, they're absolutely licensed. Open source, you don't have a kind of, you will have in the Express edition in SQL Server. Oracle also, it's on own very limited features. You can't operate much data on that. Okay. If you talk about Postgres and MySQL, they are open source. They can operate any amount of data. They are free, absolutely. That's what is a mix of open source and proprietary. Here, fully open source, and also you have a licensed version also, but there are no limitations. Open source has all the data operation capabilities except the features like inbuilt data compression, in transit data compression, and like monitoring and auto upgrades. There are such things are missing pieces. If you go to the paid version, then only get them. Mostly standalone, mostly clustered to get the actual benefit. Single point of failure, no single point of failure. Asset property, base property. What is base? We'll talk about in the architecture, not now. Need highly classic hardware to run the server. Here, just cheap hardware is also fine. Costly, average. Compared to enterprise version, here the licensed version, it is very costly. It is average, just average compared to, if I'm paying $100 for the Oracle, for if you compare with the Mongo, you might pay $7 to $8. So 7 to 8 to 100%. So see the ratio of the licensing differences. Okay, if you compare with the Oracle to SQL itself, you are paying $100 for Oracle. SQL you pay somewhere around $30. So Oracle damn costly anyway. So what kind of different products we do have in MongoDB? We have Redis Server, Memcached, Scalaris, and MongoDB, CouchDB, RavenDB, Bigtable, Cassandra, HBase, Hypertable, Infinite Graph, FlagDB. These are all different products in NoSQL family, out of which HBase is one of the famous, Cassandra is also famous, and MongoDB, and um, Redis cache also should be there. I mention here Redis here Redis server. This also getting popular nowadays. It's a caching server. Everything runs in the cache. Everything. So how this is using one of the Oracle system. So they have the Oracle. They have the Redis server. So everything will be operated here, and they get synced to Oracle, and all the data in the memory. They operating in the memory, responding from the memory. It gives so super performance. When this get rebooted, all data is gone. Again, it will warm up the entire cache from the physical server. So Redis cache is also bit of popularizing in the market, but compared to in the entire NoSQL family, HBase is a one Hadoop file system, and then MongoDB, Cassandra, Redis. These are the mostly used products. The rest of the things are situational, very limited market. But compared to MongoDB is growing badly because they are developing the product very rapidly. Every year they're releasing the new version, new features, and like their support is very good compared to any other product in the NoSQL. Support is so good from the MongoDB. That's a good point. Why it is growing. Introduction to big data. What exactly big data mean? Big data is any data that is cannot be handled and processed through a traditional single systems. In fact, there should be a group of servers should process. So it involves millions of users, millions of queries per second, billions of rows, wide variety of data at the same time. Still they scale. See, if you talk about same, this is all about Instagram, Facebook, whatsoever we're talking about social media. They're scaling. They're scaling with any amount of workload. How it is possible? Because data is segregated in the background. Data is served by different servers. Your profile is in one server, someone else's profile in another server. How it happens, we'll talk in the architecture. I'll give a good example how Facebook or Instagram can scale without a downtime. We have a discussion on that. I'll take that example when I discuss few things. Big data means volume, huge data. Variety means structured, unstructured, semi-structured. Velocity means speed. These all together is a big data. Big data means value, three V's we say, three V's. Volume, velocity, and variety. These are all put into one place and they are already they will be satisfied at one place called big data. Volume means huge data. Variety means all kinds of data like structured, unstructured, semi-structured. Velocity means speed. All can be achieved at one place. That is called big data, in fact. Vertical scalability. If you talk about RDBMS, you have single machine. You increase more CPU, more RAM, more disk to sustain with the whatever the demand that is coming from the application. At the end you grow and grow and then you can't maintain it. That's a big problem. High cost to purchase. The more CPUs you add, the more licensing cost you're going to pay, and the downtime obviously expected. When you do the maintenance little, if you have high availabilities, then downtime can be little, very little of course, but anyway downtimes will can be like in terms of corruption. Threshold and limitation, they are good, though sophisticated, they are absolutely running fine in the market, but when the data grows beyond the capability of one machine, that's where the limitations comes. Single point of failure, any small chunk of data is corrupted, entire database will be down. Horizontal, see, you run in parallel, like multiple servers are working for you, horizontally scaling, adding more machines to scale more. As your data is growing, you add more machines, the more scalability comes automatically. Less cost because of they are running on the cheap hardware. No downtime because no single point of failure. No limitation, no single point of failure, can be scaled down with any amount of data. These are all characteristics you need to understand between the RDBMS to um, you know NoSQL. Atomicity base, I don't want to really talk about this in detail. We'll talk about this architecture because architecture covers this. So what is base? Basically available state eventual consistency. By default, NoSQL does not have a synchronous data replication. It is asynchronous only. Whatever you do in the primary, it will replicate in the secondary eventually, not immediately. So that feature we'll talk about in the architecture. We'll go through this. I'm not going through much in detail here because we have this discussion. It's a technical discussion, in fact. To understand the technical, I need to start the product. First, let's go through the product, then we understand the base model, what exactly base, what exactly ACID model means. Here, ACID controls the recovery model. If the transaction fail in between, it will roll back. If it is successful, it will either it can be done fully or not done anything. So that is the ACID property. Here, it's not like that. That's why I just want to talk in the product architecture. There is a significant difference between the acid and base properties. So let's use them in the architecture in detail. Right. The MongoDB old name, the product old name is Tengen. This got renamed in the 2010, I guess. They have renamed this one to Tengen to MongoDB incorporation now. It is old name. The old name of MongoDB is Tengen. This will also be an interview question for you. What is the old name of MongoDB? Is a Tengen. Tengen is the old name. The Tengen itself renamed to MongoDB incorporation now. So this can be an interview question for you. Tengen is the old name of the MongoDB. The Tengen itself it got renamed to MongoDB incorporation now. Okay, don't confuse there. This can be a interview question too for you. A cap theorem. Cap theorem is something. This is also architecture. Still, quickly talk about this. Not much in detail because we need to understand this. So there are three properties. So let's not go through it because this is something good topic. I don't want to finish in few minutes. Anyway, just let me explain this. What happens here? Here consistency, okay, availability. Right, three topics we have: consistency, availability, partition tolerance. Yeah. So what they mean in the cap theorem, I'll explain. These are all interrelated. All are interrelated. Quickly, I'll wrap it up. I don't want to go into very in detail. This is a good topic we're going to discuss. I don't want to finish in few minutes anyway. consistency and continuous partition tolerance, then availability. So basically, what exactly it mean? If partition tolerance means the communication between the server, if this is not available, partition tolerance is not available, availability will be gone. Example, I have A server, B server. I'm giving the data to here in a synchronous format. Synchronous format. If primary is down, secondary is down, primary also will be down. In fact, why? Because it's not able to write to the secondary. Synchronous. So synchronous. If it is synchronous, it should make sure that data should be synchronous. It should not go out of synchronous at any given point. Okay, that is called partition tolerance. Partition. If the secondary partition is down, it can't write anything. Okay, availability means it is, though it is synchronous, I don't care second is writing or not. If it is not available, I'll commit in the primary, give the confirmation to the application. In fact, Postgres follows the partition tolerance. If the secondary down, it does not accept any writes. If it is a synchronous commit standby, you give it anyone, or multiple secondaries you have, one of the secondaries should be synced, that is there. If you have multiple secondaries, we can configure it basically, but in Postgres it follows the partition tolerance cap theorem. Any product follow the only two things, either CP, CA. Consistency is common anyway. See, if it is MongoDB, if the secondary down, still it will operate. Still it operates. Then where it will come? CA. This MongoDB comes under CA in the cap theorem. Okay, P is, though P is down, partition tolerance means servers. I have A server, B server, another server. I'm pushing the data here. Both are down. Assume a case. I can still write the data. This is called partition tolerance. So if secondary down, primary also will go down automatically. That is called, it's following the partition tolerance. So MongoDB does not follow the partition tolerance. Why? Because secondary is down, still you can write the data in the primary. So it will follow the CA model. Consistency and availability is important, not the tolerance. Tolerance means partition tolerance. Secondary down means primary also down. That case talks about partition tolerance. Availability mean, if we, if this one is not following example, then partition tolerance is followed. Primary, secondary down, primary also will be down. That comes under CP model. CP model, the best example is Postgres. Postgres will follow the CP model. In fact, SQL Server also will follow the CA model only. If a secondary down, still primary can commit the writes. When secondary comes, it will sync the data, though it is synchronous. So each product will follow in one of the cap theorem. In the cap theorem, no product can support all three features. Only two features out of the cap theorem, either CA or CP. That's it. So MongoDB will follow in the CA model, not in the CP model. So that is something we'll go through in detail. Product comes under which model in the cap theorem is a question, interview question. That's why we'll talk about cap theorem in one of the module, because I want to explain you after the like replica set shardings. Then this topic will come, so that you understand real in detail what I mean to say, that MongoDB does not follow the partition tolerance, does not follow. It will follow the availability. Though servers, secondary servers are down, primary still can write. Again, there will be voting. That is a different story. So that's why it is a depth subject. To understand the actual concept, what is a cap theorem, it is bit depth subject. I don't want to finish anything with a small information, guys. Don't worry. I'll give greater and more than the required information for sure. You just have to be regular to my class. I'll make sure on that. I'm working person. I have taken many interviews. I know the what is expectations from the market. By keeping all this in mind, I'll cover the course. So only thing is you have to be regular to the class. That's important. So now this is end of the discussion. Quickly run through the course content. What we going to cover? Our course designed into 10 modules. In fact, so next is a Linux administration. I know that a lot of people are from the non-Linux background. First, I'll three classes I'll cover entire Linux. Those Linux basics are enough to manage MongoDB, Postgres, MySQL, any product, all products you can manage. The basics I'll cover first in the three class. Then we'll go through the architectures. Then we'll go through the development point. Here, actual administration will start, in fact. Okay. So roughly, we will spend roughly 8 classes to 9 classes in the, like development, uh, Linux basics and all. Actual entire course of roughly 20 to 23 into pure administration. Okay. So end to end, in fact, it's not just L1 level or L2, L3 level activities we're going to do in our class. So you can see the course content in each module, what I'm going to cover. I've written in detail. So whatever is written is going to be covered in our course, in fact. Okay. So just go through it. So don't worry about the content side. Content, I definitely cover what is needed to survive in the real world or to crack the interview. Only thing from you guys I need is regular to the class. So anyone want to ask anything before I stop the video? Stay back anyway. If anyone have question, let me know. I can discuss on the video and then stop. No questions, then stay back. So I'll stop. Yeah. Everyone, you have